Hello, everyone. This is my research presentation for the class Foundation of Cybersecurity. This is an assignment that was given to us in which we have to select like three research papers and then submit the findings and recommendations. And that's what this paper is all about. This presentation focuses on emerging cybersecurity risks in AI systems, uh, especially in healthcare environment like VA. Like of VA, AI systems are increasingly integrated into clinical decision support, chatbots, and automation workflows. However, these systems introduce new attack surfaces that adversaries can exploit. In this presentation, we will examine how confidentiality, integrity, and availability are impacted by the AI threats. The goal is to inform leadership about risks and mitigation strategies. Presentation objectives. The objective of this presentation is to analyze three recent cybersecurity research papers related to AI systems. We will explore technical attack mechanisms such as prompt injection and model manipulation. Each paper will be evaluated based on strength, weaknesses, and practical implications. We will also assess how these threats apply specifically to VA infrastructure and healthcare systems. Finally, we will provide actionable recommendations for improving AI security. Theme of selected papers. AI systems introduce new vulnerabilities that differ from traditional software systems. Adversarial machine learning allows attackers to manipulate model behavior through crafted inputs. Key areas of concern include prompt injection, data leakage, and model extraction attacks. These threats affect both the training phase and the deployment phase of AI systems. Our goal is to understand these risks and improve resilience in real-world deployments. Paper one, here's the source information, the URL of the paper, and basically like what this paper is all about. And the author of this paper is UP Liu et al. And it's focusing on LLM security and vulnerabilities. Paper one, main idea. Prompt injection attacks exploit how LLMs interpret user inputs as instructions. Attackers craft inputs that override system prompts and change model behavior. This can result in unintended actions such as revealing sensitive information. These attacks typically operate in black box environment using API access. This makes them particularly dangerous for deployed AI services. Here are the technical details. The technical approach involves prompt engineering techniques and probabilistic sampling. Attackers repeatedly query the model to extract memorized data or alter outputs. The model's inability to distinguish between instructions and data is a key weakness. This allows hidden or malicious instructions to be executed. These techniques require no direct access to the model internals, increasing their feasibility. Paper 1, Strengths and Weaknesses. The paper provides strong empirical evidence demonstrating that prompt injection is a real threat. It uses real-world scenarios to show how LLMs can be manipulated effectively. However, some attacks require a large number of queries, which may limit practicality. Defensive techniques are still under development and not yet standardized. This highlights the need for continued research in AI security. Paper one, relevance to VA. For the VA, this presents a significant risk to electronic health record systems. Sensitive patient data could be exposed through manipulated AI responses. This raises concerns about compliance with HIPAA and federal security standards. Strong governance and validation mechanisms are required before deploying AI systems. Security testing must include adversarial scenarios to prevent exploitation. Paper 2 source information. This paper I found on the ucnix.org website. It has been authored by C.G. Chen et al. And it focuses on defense mechanisms. The paper introduces a struck defense mechanism against prompt injection attacks. It proposes separating user input from system instructions using structured queries. This approach prevents malicious input from overriding system behavior. The research focuses on improving security without significantly impacting usability. It presents one of the first practical defenses against prompt injection. Prompt injection occurs when user input alters the intended logic of an AI system. This can cause a system to execute unintended or malicious instructions. Attackers can exploit this to bypass safeguards or extract sensitive information. Such attacks are particularly dangerous in chatbot and automation systems. They are easy to execute and difficult to detect in the real world environments. Paper 2 technical details. Technically, prompt injection works by embedding malicious instructions in user input. The model processes these inputs as a part of the instruction set. This leads to unintended execution of commands or data exposure. These attacks can be applied across multiple AI-driven workflows. They highlight a fundamental design flaw in current LLM architectures. Paper 2 strengths and weaknesses. The strengths of this research include realistic attack scenarios and practical demonstration. It shows how easily attackers can manipulate AI systems using simple inputs. However, implementing defenses can impact usability and system performance. Detection mechanisms are still evolving and require continuous monitoring. This creates a trade-off between security and functionality. Paper 2 relevance to VA. For the VA, prompt injection poses risks to AI-based chatbots and support systems. These systems may handle sensitive patient or operational data. Attackers could manipulate workflows or extract confidential information. Input validation and monitoring are critical to prevent such attacks. Security policies must be updated to include AI-specific threats. Paper 3, source information. The author of this paper is Nasi et al., and it is about modeling AI attacks as a multi-stage process. It extends traditional cybersecurity chain to AI environment, provides structured understanding of AI attack life cycle. And this paper is on the arxiv.org website. Paper 3 main idea. A model extraction attack involve querying AI systems to reconstruct their behavior. Attackers collect input-output pairs and use them to approximate the model. This allows them to create a replica of the original system. Such attacks threaten intellectual property and sensitive decision logic. They are particularly relevant for cloud-based AI services. Paper 3, technical details. The technical approach uses repeated API queries to learn model behavior. Attackers analyze outputs to approximate decision boundaries. This process is entirely black box. So nobody can see inside what's going on in the system. And so they have to basically rely on the input and the output to come to formulate their decision. The process is entirely black box and requires no internal access. It is effective against many deployed AI systems. This makes it serious concern for organizations using AI APIs. Paper 3 is strengths and weaknesses. The research demonstrates that model extraction is feasible in real-world scenarios. It highlights vulnerabilities in API-based AI deployments. However, some attacks require high query volumes, which may be detectable. Rate limiting alone is not sufficient to prevent these attacks. A combination of security controls is needed. Paper 3, relevance to the Department of Veteran Affairs, the company I worked for. And for the VA, model extraction could expose healthcare analytics models. This could reveal sensitive patterns in medical decision making. And I apologize, in medical decision making systems. Such exposure could lead to misuse of adversarial attacks. A strong API security and monitoring are essential. Organizations must protect both data and model integrity. Here is like a brief comparison of the three papers. Each paper highlights a different type of AI security threats. Data extraction affects confidentiality, prompt injection affects integrity. Model extraction impacts intellectual property and system security. Together, they demonstrate the broad attack surfaces of AI systems. This reinforces the need for comprehensive AI security strategies. Integrated security challenges. AI systems significantly expand the cybersecurity attack surface. Organizations must adopt adversarial testing to identify vulnerabilities. AI governance frameworks are essential for secure deployment. Continuous monitoring is required to detect emerging threats. Security strategies must evolve to address AI-specific risks. Defensive architecture for VA AI systems. A strong defensive architecture includes zero trust principle for AI systems. Prompt validation ensures that inputs are safe and properly structured. Differential privacy can protect training data from leakage. Rate limiting and anomaly detection help identify attacks. Red teaming and adversarial testing strengthen system resilience. Here are my recommendations, basically based on the findings that I was able to like get from these three papers. The VA should conduct regular AI security assessments to identify vulnerabilities. Strict access control must be implemented for AI systems and APIs. Staff should be trained on emerging AI-related threats. AI security should be integrated into the overall cybersecurity strategy. This will help ensure secure and resilient AI deployments. This is the list of all my references, the papers that I basically like looked at to in order to like come up with this presentation. And to conclude, AI security is an evolving field with significant implications for healthcare. The reviewed papers highlight critical vulnerabilities and emerging threats. Organizations must proactively address these risks through strong security practices. The VA can benefit from adopting advanced security framework and continuous monitoring. Ongoing research and awareness are key to maintaining secure AI systems. This concludes my presentation. I hope I was able to provide information that you can benefit from. Thanks for watching my video.